Hey guys, Max back with Max Tries, and in this video I'm going to give an overview of engineering basics for Vibe coders. I am formerly a product manager turned product developer, coding with AI, and have recently built a few projects, and I thought it'd be really helpful to share some of my learnings for those who are not engineers, don't have software development background, but are starting to build with AI. In this video, I'm going to talk about architecture, API keys and environment variables, security, caching, indexing, feature branching, and load testing. To start, I'd love to show my website that I built. It's called catholicgo.com. I recommend you check it out. It's a directory for Catholic sites in the United States to make micro pilgrimages to. So quick layout, we have this home page. You can see that you can enter your email and download the free guide. We have some featured destinations here. We have 6. You can click into each of these and you can see and learn about each of the locations. We have some basic navigation as well. Start exploring. You can see a search page for all of the sites. You can search by category, for instance, monasteries, or by states. Say Connecticut, find different states there. Or of course, free text search. We also have an interactive map, so you can click on it and see all the sites within the United States. You can click into it and see the individual site as well. So I built this as a project and it really forced me to move beyond just accepting Claude Code edits and the AI edits and really understanding the underlying software and technology beneath it. I'd say the coolest part about this is as a product developer, you don't actually need to be writing the code itself, writing the functions and things like that, but you do need to be able to understand what's happening and how things are related to each other, how the data is flowing, and how things are organized and stacked and integrated with each other. If you can do that, you can ask really good questions and prompts for the AI. You can help put the guardrails up, and you can build projects like this that I'm actually really quite proud of. I'll be going back and forth between my site and this site, which I built as well to try and visualize the different components and aspects of software development. So engineering basics for Vibe coders, from user click to database query. So the most important thing for me was learning what is the architecture and what are the main components of the software development stack. So I thought of it in terms of you have your user who is arriving on the page. You have a CDN, which is a content delivery network. I'll get into that. You have your hosting provider, which is rendering your website. You have your backend server slash API that is where a lot of the magic happens in making certain calls and rendering information. And then you also have a database. I've been using Supabase, where a lot of that raw data is stored. So I've been using Railway, and Railway is both the hosting provider, which renders the HTML, the website, but it's also the backend server where it's running jobs and fetching data and telling the website what to provide. I love a good analogy, so we're gonna try and stretch a restaurant analogy as far as possible, and then I'll show you exactly how that relates to my catholicgo.com website. So we have the front end, which is really what users are going to see. It's the dining room. It means the UI, the UX, forms for submitting a testimonial or signing up for the newsletter or the PDF. The front end is what users are seeing and interacting with. The CDN is really like a waiter's station. It has a bread basket ready. It has water pitcher refills. So as soon as someone comes into the dining room and sits at a table, they can immediately get water. They can immediately get bread, and the server doesn't need to go to the kitchen to get food or anything for them. It's just instantly available for them. We have the back end, which is the kitchen, and that's where the meals are made, ingredients are fetched, and meals are prepped and then eventually sent out to the dining room table at the front end. And then finally, we also have database. This is really like the supplier or the pantry. This is where raw ingredients are stored, raw data is stored. Um, if any updates are made, it is often to the database, and then it propagates through the whole system. So how that applies to Catholic Go is we have our front end here, right, where we can see we have styling, we have fonts, a background video, and you'll see when it loaded immediately. So if I go to explore featured sites, they're there available immediately. So that the waiter station and as a user, when I come to this website, it knows, hey, let's immediately serve up these featured sites. The way this is built out is that we have a database full of all of the Catholic Go sites. We have categorized them by whether they're featured or a church or a monastery. And what we've done is the server, the backend server, has fetched that data from the database and then cached that on the server itself. So when a user comes to the website, the server doesn't need to make another call to the database to retrieve all that information. It already has it right there locally, and so that it can deliver it to the user very quickly. And then there's rules and logic for the server to periodically check with the database to see, hey, if there are any updates, if there are new sites. The goal is to limit the amount of queries to the backend database because it costs less, it's more efficient, and it creates a better user experience because you can deliver the information and images quicker and faster. One of my other big learnings was really around API keys and security and environment variables. So a horror story, so I'm told from the internet, is if a developer pushes their API keys into GitHub, bots scan GitHub in seconds, the keys get stolen, and an attacker racks up $50,000 in AWS charges overnight. That would be horrible. Um, One thing about this, though, is where are you is the repository that you're pushing your code to in GitHub, if it's private or public? I have all my repositories private, so even if I did make a total blunder like this, at least the repository is private, but you still don't want to be exposed to that. So the main thing about, well, let's talk about API keys first. API keys are the keys or the handshake that allow different services to talk to each other. So as I mentioned, we have that backend server, and then we also have that database. So in order for them to communicate and exchange information, there's an API key that both of them have that allows them to authenticate, authorize, and send data back and forth between them. For instance, I have there's an API key for Supabase, which is my backend. If you're integrating with a payment processor like Stripe, you might have a API key with them so that you can communicate between the two services. Also, if you were integrated with one of the large language models, you would have another API key. So it's really just the keys that enable the transfer of information between different services, typically outside services. Now that we understand how API keys work, the other big learning for me was about environment variables. So when you are developing code on your laptop, you're working in your local environment, you're in your dev environment. And so you have a file called .env or .env local, which stores all of your local environment variables and API keys. So in your environment variable, you have your Supabase API key, your OpenAI API key, your Stripe secret. Like you have all your keys to the house in that environment file. When you push your code to GitHub, you do not want to be pushing the keys, your API keys. It's just a huge security risk. So what we do is that .env file, we add it to gitignore, which means that when we are pushing code to GitHub, it ignores all of the files that are within gitignore. However, the code knows to be looking for the API keys for those certain areas. And so we must add those API keys in the production environment. So let me show you what this means, really. When you're developing locally, you create a .env file, and here you add all of your API keys because you're developing locally and you need to be able to test the services. I need to be able to test adding a new Catholic site. I need to test fetching my Catholic sites or updating them. The system, you want a complete working system in your local environment, and so you must have those API keys there. But then we add that env file to get ignore. So which means that those keys that allow for the transfer of information are no longer getting pushed to GitHub as part of the code. Then, and here you can see like what the code looks for. It's just saying, hey, get this API key. We never hard code the API key. Then once you get to production, so I'm using Railway for my server for both like serving the website and the backend server. And in Railway, I set my API keys for production. So the code says, hey, you need to look for the Supabase API key. And then the production environment variable says, here's my list of secure API keys, use this one. And that's how we keep it really secure and safe, both your API keys and using the environment variables. One of the easiest things to do as well with vibe coding is security audits. I certainly don't know best practices when it comes to software development, security, and code. However, Claude does. And so one of the easiest things I do is just ask Claude. I say, do a comprehensive analysis, security audit, and analysis of my code base, and let me know what I need to fix. And more often than not, it will come back with a couple different recommendations that are easy enough to, follow prompt and get Claude to fix. But before pushing any major code, I always recommend just ask Claude to do a security audit and make sure that your code is safe and following best software development practices. Never commit environment files, always add them to git ignore. Your front end is public, your back end is private. Rotate compromised keys, so it's pretty easy to rotate keys if they get exposed. And then finally, do regular audits. The next topic I want to talk about is caching. As previously talked about, caching is a way for storing images, files, API responses on edge servers so that they are easily and quickly retrievable by the end user, but also more importantly, it is not making additional requests to your database where you pay for data egress from your database. So minimizing the amount of requests to the database is not only makes it more efficient, but is cost savings as well. One of my big learnings is that there's caching on multiple layers. So there's caching on the CDN, which is the edge server, which is storing that local image or API response. There's caching in the browser, which is really where the user is coming from. And then there's also caching on the backend server as well. So as a quick example, for the Catholic Go website, we have browser caching. So if the same user comes back to it, the information is already there and ready. We have server caching. So if a new user comes to the website and they look at these featured destinations, the server is not having to go query the database again. It already has the featured destinations cached locally in memory, and it can render those very quickly for that user. An example of this is the user visits the site. If they had already been to the site, their browser had cached the various elements of it, like featured sites, images, text, things like that, and it would display instantly. If they had never been to the site before, then the server has cached that information and it can serve it up to that user very quickly. And then finally, the CDN also caches the information. So sometimes the server will it'll cache API responses saying these are the 6 featured sites that we have, but for the images for each, those are all cached on the CDN. It's the content delivery network. So the caching works in parallel, where the response of like which sites to display is cached, but then what images to display for each of those sites is also cached from the CDN. So it just makes it so the page is ready very quickly. Without caching, the user would, um, you know, access, go to the website, it would go to the server, they'd have to download, it would download all the HTML. The server would then have to query the database to get all of the featured sites. It would then have to download all of the images and then finally render it back to the user, which makes for a really slow process. Um, Again, as I mentioned, like even if I do a hard refresh here, all the content is here and quickly loaded because it is cached both in the browser, but then also on the server. So not making calls back to the API, to not making calls back to the database. So what to cache? Cache, for me, is caching featured sites, images and media, popular API responses. So when I click featured sites, explore featured sites, what this is doing is actually searching the database for all of the featured sites. You can see that there. You can see that these are all featured. And so when I tap that, I had already done that query and I had already saved all those responses in the cache on the server. So it is able to just render those very quickly. Cache duration, depending on what it is you're caching, you can set for the duration for how long it remains in memory. So pro tips: cache expensive queries, set smart expiration times, clear cache on updates, and monitor cache hit rates. Okay, the other thing I learned about was database indexing. So I have this wonderful database with Supabase. It has multiple tables. It has a list of all of my sites, and it is really robust and growing. The best way to describe database indexing is like searching a library with and without a card catalog. Without the index, it goes and checks every database row by row, column by column until it finds the thing it's looking for and returns it. With an index, it allows you to jump right to the shelf and know exactly which thing to pull. So it makes the queries much, much faster. An example of this is featured sites. When I'm searching the database for featured sites. So as I mentioned, I had cached that API response in the server, but every so often it's going to go back to the database and fetch all of the featured sites. And so without indexing, it will go through and look through all of the sites and then return that response. A very slow process, which then could, a very slow process. With the indexing, it knows exactly what to look for, where to look for, and then can return that information much more quickly. Okay, this one's really simple, but I wasn't doing it initially, and I got caught up, and it caused some trouble for me. But the main idea is feature branching. When you're developing locally, create a new feature branch for each feature. What that allows you to do is really separate different types of work. So, for instance, if you're working on main, you could create a new feature branch for this mobile fix, and then you can, even if you don't finish that work, it's okay because it's separated, and then you could start another feature branch for say Supabase migration. What I had done was I started working on all these different features just within the main branch, but then some of them got to a state where they were done and ready to go, and by go I mean push to prod, and others where they were incomplete, and it was very difficult to separate that work. So create a unique feature branch for each feature, and then once that's complete, you can merge it back into main and then push to prod, push to GitHub. Main benefits are it's isolated development, easy rollback, and parallel work. You can work on multiple features at once and not be worried about when each of them finishes. Finally, last but not least, load testing. So you can do this with artillery. It is through the command line with Claude, just ask, hey, do some load testing with artillery. And what this does is simulates user traffic on your production website. This is key because it generates a really helpful report that shows at what point does your website start to break? What point are your API responses slowing down? And for me, this was really helpful because I did some initial testing and I could see around 50 users per second that some of the responses were slow. And that helped me diagnose where to add additional caching, where to add certain improvements to improve the speed and efficiency of the site. Imagine if you go viral and your site crashes, that is not what you want to do. So it simulates traffic, you're able to measure performance and find breaking points. It's really simple. Just tell Claude to run a load test with artillery and it will do it. Um, Again, test homepage, places with the most traffic, search functionality. You'll learn about your response times, error rates, throughput, your breaking point, and any bottlenecks. And again, the bottlenecks is really where I was able to learn about adding more caching, adding the database indexes, optimizing slow queries, and adding CDN for assets and things like that. And so when to run load tests, do it before you launch, after any major changes, before big events, do regular checkups. It's really easy to run load testing with Claude, and you will be happy that you did it. And that's it for this section. As always, I really appreciate you watching, and please let me know if you have any questions. I'm happy to answer them in the comments, and we'll be back soon with more videos. Thanks so much.